So here's a couple of recently released motors from RacerStar from Banggood. These are the RacerStar BR2307S-2500KV Green Edition and RacerStar BR2406S-2600KV. So I bought these motors from Banggood because I thought they looked interesting. Budget motors, kind of cheap, you know, around 10-11 bucks each, and pretty good size on these motors, 2307 and 2406. So I thought I'd purchase them and just kind of test them. I actually got them a long time ago when they first came out, whatever it is, a month or two ago. So finally I had some time to test them and do the video, so here they are. And I'm just going to do the overview, both of them at the same time, and the thrust test would be on two separate videos so that I can get them out quicker. So as usual, they come in these boxes, just minimal stuff on the boxes, just some bubble wrap and some mounting screws, and that's about it. The motors themselves do come with matching nylocks, so that's good, matching color. So these are the green ones, and I think this is just paint, so you can easily scratch it. So it's not like the more premium motors, you know, it's not anodized, so it's just paint, but that's okay. It is a budget motor, only around 10 bucks each. So here we have the 2307 and 2406. So you can see the size differences there. Not too apparent. I mean, the size difference don't jump out because it's only 1 millimeter diameter and 1 millimeter in height of the stator. So you gotta look closely to see the difference, but it is there. It's gonna be interesting to see how these two motors do. The KV is pretty close, and we're only changing the stator size. So this one has a taller stator, but a smaller diameter. This one has a little bit larger diameter, but shorter stator. So that's gonna be interesting to see how those differences end up as far as performance. Pretty much standard construction on the motor, standard design, just a full base. They're still not going with the naked bottom, you know, the minimal base. But still, even though the motors are budget, they still include some of the good features that we've been seeing in premium motors or in premium brands. So that's good. But not much information as far as what material is used on the RacerStar Banggood product page. So they don't mention what kind of aluminum they're using. I imagine it's 6061 because this is it's a budget motor, so most likely it is 6061. And the shaft are single piece and they are hollow all the way through, so pretty nice touch for being a budget motor. So on both, as you can see, they're fully hollow. And so I imagine these are just hardened steel. Hopefully it is hardened. It is stainless because it's not magnetic at all, so that's actually quite nice. You know, they won't rust. Some shafts do rust because they're not stainless. So those seem to be stainless. It's not magnetic at all. So that's good. And they're using just a regular circlip to retain the shaft in place. So I already took it out here so I can pop this out. And they do have some brass spacers there. And circlips, they're kind of a pain sometimes to remove. Some people prefer just screws. But this being a budget motor, so can't ask for more. And there, more or less, you can see the air gap. It's not too bad. It's pretty decent, I think. Not too tight, not too loose either. And the magnets, they do appear to be just standard magnets. They're not a curve or arc magnets. So again, that's okay for a budget motor. So the wires they give you, they're a little bit on the short side, so that's just one criticism I have for these motors. Just wires are too short. I think most people these days, a lot of people anyways, are using 4-in-1 ESCs in most builds, especially if they're going for the ultralight builds. So you would want to have at least 110 millimeters of wire. These are pretty short. These are only about 75 millimeters, so not enough to reach the center mounted ESC. Let's get the way of the motors with the 75 millimeters of wire. This one's the 2307, and that comes in at 35.8. And let's look at the 2406, and that's 35.1. So kind of interesting to see the 2307 weighing a little bit more than the 2406, but it doesn't make sense, you know, because if you do a quick calculation on the stator size, as you know, the volume of a cylinder is pi r squared times the height. So you know, if we put in the values for each of these, the 2307 will have that's 3.14. Will have a 11.5 millimeter radius, and the height is 7. So that comes in at about 2908. So 2908 cubic millimeters. Of course, that's simplistic. The shape of the stator is much more complicated than that, so you'd have to do a different kind of calculation to calculate volume. So now let's look at the 2406. It's gonna be 3.14, that's pi, and diameter is 12, and the height is 6. So that comes in at 2714 cubic millimeters. So as you can see, quite a noticeable difference in overall volume. Again, this is simplistic, but just to show you what the differences are. So the 2307 actually has more what they call iron material on the stator. So meaning the stator itself, because it's taller, is actually containing more iron than the 2406. So in theory, the 2307 is going to produce more magnetic force than the 2406 stator. So we'll see that on the thrust stand, and when you compare the results, when I get these tables out, you can compare it side by side, and we'll see how that works out. Right, so the circlips are removed, so let's pull this apart and have a closer look on the magnifying glass. So these pop out easily on both. So there we go, and let's have a look under the magnifying glass. Alright, so this is the 2307, and as you can see, okay windings, not the nicest looking windings, but again, keep in mind this is a budget motor, so that's in line with its price point. Lamination seems to be 0.2 millimeter, if not thinner. They certainly look really thin, so it's good to see that you know, the motor is including a lot of the premium features, even though this is a budget motor. I believe they do mention that the bearings are NMB, so hopefully they are, so they'll last plenty long. And these are pretty good size bearings. They're the 4x9x4, so usually those bearings do pretty well. It is multi-strand wire. Here's the bell with the magnets. As you can see, just standard magnets. I don't know what grade of magnets, if they're M48 or M52, and plenty of, looks like plenty of epoxy there, so they should stay in place quite well. There's the single piece 4mm shaft and balancing mud right there. Here's the 2406. So there you can see the difference in stator. Not really apparent. I mean, you can't really tell the difference, but it's only 1 millimeter. But yeah, I mean, if you look at it closely, you could tell one's larger than the other. And same thing. Here's the stator. They're very similar. similar construction on both. So overall, pretty decent looking motors. So the one thing to find out if it's how durable they are. So I'm sure already there should be plenty of comments as to how durable these motors are and how well constructed they are, and about the bearings. Sometimes, you know, where they cut cost, it's going to be on the materials used in the motor. So bearings would be one of the first places where they would cut down costs. So hopefully these bearings are pretty decent and they last a good while, so they don't fail prematurely. And also the material of the motor, they don't say if it's 75 or 6061. Most likely it's 6061. At that price point, I wouldn't think they would use the more expensive 7075. Okay, so we'll put these back together and put them on the truss stand and get some numbers so we can compare to against each other and against other motors of similar size. So that's gonna be interesting to see how these budget motors perform. Alright, so let's look at the thrust test results for the RacerStar BR2307S-2500KV. As you saw, the motor came in at 2620 as measured by the thrust stand, so quite a bit higher, noticeable difference, 120 kV, but at least it's in the right direction. 2600 is not too bad, I think. A lot of people preferred a little bit higher kV for 5-inch props. So based on that kV, I tested on 3S, 4S, and 5S. The usual props, starting with the GenFan 5045, so almost reaching 1400 grams at very reasonable amps, only 38 amps. Once again, as I always mentioned, keep in mind these amps are from static thrust, so they're gonna be a little bit exaggerated. Don't be too concerned with the high amps. This is just static, and all motors that I put on the thrust stand are gonna show really high amps because of just the nature of the test, static, and there's a single motor drawing from a dedicated power supply. And also keep in mind that these are maximum burst amps, so that only occurs under the most extreme conditions, and that's what I show here. In actual flight, you'll be seeing maybe about 35 to 40% less. So the next prop is the HQ 5043x3, so that's almost 1500 at 1487 at 42 amps, so still pretty manageable. I ran that one on 5S, and that yielded almost 2 kilograms, so that's pretty good thrust at 54.5 amps, so still pretty reasonable, I think. I threw in this 5.5 prop from HQ. So I threw in this 5.5-inch prop from HQ. This was not a particularly efficient prop. Actually, I was kind of surprised. The bullnose version of the HQ 5.5-inch prop, it's actually better. So that was kind of interesting. I'll
I have the results for those 5.5 props and the master air screw props. I just gotta put them together in a video, so keep an eye out for those. Then onto the heavier 5-inch tri-blades, 5046 and the 5045x3. So that's 1569, 1582, pretty good thrust there. And then onto the 6-inch props, breaking the 1800 gram mark pretty easily. Then onto the Dial TJ 6045x3, a 6-inch tri-blade, also making over 1800 grams, but at a higher amp usage, so not as efficient as the 2-blade props. Also tested on 3S, so there's the numbers if anybody wanted to know. And there was a puff of smoke with this prop, possibly because the windings on the stator, the wire use, is not as sturdy as in other motors. But, you know, we got to keep in mind that we're overstressing the motor here on the thrust stand. 67 amps running through the motor, that's quite a lot. But in the air, it could be okay because the amps are going to be a lot lower, around 35% lower. So the motor is not going to be subjected to this much stress. That shows you the quality of the components used on the motor. Of course, this is a budget motor, so they're not using top-notch wire. So that's why sometimes we get a puff of smokes where other motors won't show that. But it doesn't mean that the motor cannot run this prop in the air. It's gonna be unloaded. Same thing happened with the 7045 on 3S. There was a little bit of puff of smoke, but I think I should be able to run it. But still, you know, make sure you check the temps if you run these props on these motors. I would go for a quick lap, maybe 75% throttle. Come back, check the motor temp. If it's not hot, then keep going, go to 100% and check the motor temps again right away. But I think it should be okay. Then finally also tested the HQ 7045 on 3S. Pretty decent number there. I didn't want to test it on 4S because I thought it might be a little bit too high amps and I didn't want to damage the motor. But I think in the air it should be able to handle it. Though if you use it, just make sure you check motor temps after a short flight, just in case. So overall, pretty decent motor. As you can see, pretty decent performance. So this should be a good option for using it with the heavier props. I don't think it makes sense to use it with a 5-inch prop because of the weight of the motor. There's better options. So maybe with 6 and 7-inch props, this motor would match better. So the only thing left to know is to see if the motor is durable and it can survive the abuse that we put these motors through. I'm sure there's already plenty of reports on this motor since it's been out for a while. So it would be good to check out those reports. Okay, that's the thrust test for this motor. Thank you for watching and until the next video.